Well, thank you for having me. It's been wonderful to be here, and I'm excited to tell you a little bit about the work that I've been doing with my colleagues. So I'm what I would refer to as a cognitive scientist. I try and understand what happens in the brain and body as we learn particular skills, so as we get good at whatever we're interested in. And I'm also very interested in why we sometimes fail to put our best foot forward. This is when we've practiced to perfection, when we've studied really hard, when we prepared for a meeting, and all of a sudden, when the stakes are highest, when all eyes are on us, we just can't show what we know. So in my lab, we try and understand why we sometimes fail to perform up to our potential, especially when the stakes are high. And the goal is that if we can get a little insight into the workings of the brain in these high stakes situations, then we can actually start to develop easy to use and easily to implement tools, a toolbox of techniques, if you will, that we can all use and harness to perform better in our daily lives. And so today I'm going to take you through a bit of a whirlwind tour and tell you about some of the work that we've been doing and some of the findings related to performing our best and sometimes our worst under stress. And in my work, we study a variety of different situations, from the athletic field to the classroom, to the boardroom, to the performance stage, to public speaking. Public speaking is an interesting one because if you actually survey Americans about their greatest fears, death is first and public speaking is second. So we've learned something about how individuals perform in these types of situations, and we're starting to harness that to figure out what we can do to perform our best when it matters most. So I want to start by telling you about what we think goes wrong when we're under stress, and a lot of it has to do with what's happening in the front part of our head. It's called the prefrontal cortex. And this is the part of brain that really separates us from other species. If you look at the size of our frontal cortex compared to even our closest primate relative, what you can see is that our brain, if this is my brain, I'm just turned this way, the frontal cortex is comparatively larger than even our closest primate or mouse relative, but it also takes up more neural real estate. Our frontal cortex occupies a larger part of our brain than on other species. And the frontal cortex is really what allows us to do the amazing things we can do as humans. We can hit that tiny little ball into the tiny little hole, largely because of our frontal cortex. We can juggle numbers in our head. We can come up with that response on the fly. All of these things have to do with an adequately functioning frontal cortex. And in stressful situations, it turns out that our frontal cortex actually doesn't work the way it should. One of the seeds of the abilities that comes from our frontal cortex is our ability to focus on what we want and get rid of what we don't. And in stressful situations, because we're often worried about performing at such a high level, we actually often focus too much on the wrong things. I talk about this as paralysis by analysis. It's this idea where we want to perform at such a high level, we start monitoring what we're doing in a way that disrupts us. It's as if you were shuffling down the stairs and I asked you to think about what you were doing with your knee. This is something that largely runs outside of conscious control, but in stressful situations, we start trying to monitor all aspects of what we're doing to try and perform at our best, and we actually disrupt it. And you can see this in all sorts of examples, but sports is really my favorite. And one of the best examples comes from, I think, golf. This is a picture of Jean Van de Velde. Jean, his name actually is now French for choke. He was going to be the first Frenchman ever to win the British Open in the late 90s. And what happened to Jean is he was 4 shots ahead when he got to the 18th hole, and he fell apart. He had, I think, one of the most epic chokes of all times. His first shot ended up in the trees. The second one hit the grandstand. The third went into the water. And this is the picture that was on every sports page the next day. He actually took off his socks and shoes and went into the water and was deciding whether he was going to hit the ball out of the water. He decided to take a penalty. He ended up in a tiebreaker round and lost. It was just really heartbreaking to watch. But one of the interesting things, if you go back and look at the tapes, is that he looked different on this last hole. He took a lot more time sitting over the ball than he normally would. And we think this is really indicative of this paralysis by analysis, this over attention, because it takes time to deploy that attention. It takes time to focus. And we've shown in our lab, which we actually have a putting Green is one of our laboratories, we've shown that when you bring skilled golfers in and you put them under stressful situations, all of a sudden they start thinking about the details in a way they wouldn't otherwise. They slow down what they're doing, and their performance is often disrupted because of it. So it's a bit of a counterintuitive idea, but when we're in those high stakes situations, there's a time to practice and think about what we're doing. When we're in the high stakes situation, we should better go by the Nike motto of just do it. Get up there and hit the shot. Go out and give the talk. Don't dwell. And if we're concerned that we are about to think too much about the details, there are some things that we can do. We can actually focus our prefrontal cortex. So in sports, for example, one swing thought, one mantra that encapsulates the entire stroke is a great way to ensure you're not breaking down those details on the putting green. Thinking about the outcome, where you want the ball to land, rather than the steps you're going to get there. When you're raising your hand and everyone's watching you to ask a question, or when you have to pitch to a client, thinking about that one take-home aspect you want to get across allows everything else to unfold. It gives you that mantra in a way. And of course, it's also a really nice thing to have in your back pocket if you're playing with your buddy on the back nine and they're beating you solidly. You just say to them, "That was a great shot. What were you doing with your elbow?" Okay, so paralysis by analysis is one thing that seems to happen in these high stress situations, but we know that's not it. Our frontal cortex helps us focus our attention, but it works in concert with the rest of the brain. And one thing that tends to happen in high stress situations is we get this tunnel vision. We often dwell on details we shouldn't, and we don't see the big picture. And this, as a result, often makes us less creative. We're less likely to come up with the important solution to a problem in the moment. You see this all the time in business situations where it's crunch time, and the obvious solution or the challenging solution that you might not have normally thought of just doesn't come to the surface. And interestingly, this sort of stressful situation doesn't have to be the one-offs. It doesn't have to be as you're at the 18th hole or giving that speech. It can happen just because you're in high-stakes situations in general. Maybe you're having a rough time with your company at work, or there's stress in home. Just being under the stress of something important occurring can change our ability to think outside the box, think creatively. And one of the best examples, I think, of this comes from a study done at the university, at Cornell University. Researchers asked med students who are studying for their medical school boards, which is a very stressful time. They invited them to their labs to have their brains scanned while they did a bunch of creativity and thinking tasks that required these students to think outside the box. They invited them to their labs, and they also invited a group of med students who were matched on age, education. Everything was the same, but they weren't under the stress of studying for the medical school boards. This was about 2 months before the medical students took their boards, and what they asked them to do were some fairly simple tasks. So here's one example. So you guys get to be my subjects for a second. So each of these is a different task, and your goal is to come up with one word that forms a compound word with cadet. The same word forms a compound word with capsule, and the same word forms a compound word with ship. You're looking for one word. Does anyone know what it is? Space, right? Space cadet, space capsule, spaceship. So now you get the hang of it. What about the second one? Safety pin, pin cushion, pin point. The third one? Ball, right? Basketball, 8-ball, snowball. They had them do tasks like this. They also had them do tasks that required a little more outside the box thinking. So here's another one. This is called the matchstick game. And each one of these, again, is a separate line. Your goal is to move one stick and only one stick to make the equation true. So how do you solve the one at the top? So you move the stick on the far left to the right of the V, right? What about the one on the bottom? So making a V moves two sticks. There you go. What you have to do is think outside the box. We tend to think of the plus sign as one unit, but I never told you you had to do that. And all you have to do is take this vertical line on the plus sign and turn it to make it an equal sign, right? So this requires some outside the box thinking. It's a fun game to play. And what the researchers did is they looked at how the Cornell medical students, under the stress of studying for their exams, did on tasks like this compared to the people who weren't under the stress. And sure enough, they showed that the Cornell medical students were more sluggish. They weren't as good at answering these types of questions. The students were doing this while they were having their brains scanned using a technique called functional magnetic resonance imaging. So it's really, what this is it's a big magnet. You might have had an MRI on your knee or your shoulder at some point. And as neuroscientists, we use this technique to actually peer inside the head, to open up the head, so to speak, without actually opening it up. So you can put people in this, we call it a scanner, it's a hollow tube. You put them in, they're lying on their back, and they usually have a computer screen over them, either with goggles or a computer screen comes down, and they can answer questions with buttons on either side of them. So you can put these equations up, and you can make different ways to have them answer them, or you can give them options and they can answer different questions. And when the researchers peered inside the heads of these students, what they showed is that for the students under the stress, that frontal cortex wasn't communicating as well with the rest of the brain as it was for the students who weren't under the stress. And it was if they weren't able to call to mind alternative solutions or see the problems in new and different ways. And this is interesting because they had no pressure to perform this task. They didn't really care how they did on this task, but just the pressure from one area of their life could spill over and affect their functioning in another. This is actually really important because it suggests to us that we have to be better at thinking about how stress in different aspects of our lives can affect functioning. As an example, if you have a fight with a spouse at home and then go to work, that can actually change how the brain functions as you're trying to go about your day. And if you are the proud parents of teenagers, you probably don't want to have that fight about curfew in the car the morning they go to take a test. Our brain doesn't distinguish between one situation and another. We need to make sure that it's functioning optimally at all points of time. Now, the good news is that the Cornell researchers brought these medical students back in 2 months after they took their boards, and they looked as good as new. So the stress doesn't last forever. But the issue here is that our creativity, our ability to think in new and unusual ways can be stunted because of this malfunctioning prefrontal cortex. And it doesn't just have to be that stress in the moment, and it can extend to all aspects of our lives. So I've talked to you a little bit about this paralysis by analysis, focusing on the details, also this stunted creativity where we have these blinders on. Something else that happens when we're under stress, and I think we've all experienced this in our lives, is that we might act in an emotional way or react in a way we might not normally do. And this really has to do with a loss of emotional control. And the reason, again, comes back to this front part of the brain, because not only does this front part of our brain help us focus on what we need to and get rid of what we don't, it actually serves as an important gatekeeper for more evolutionarily ancient emotional regions of the brain. What the frontal cortex does in normal situations is help damp down reactions from areas like the amygdala or the insula, which are our alarm signals in a way. And in most situations, we're pretty good at that frontal cortex being the gatekeeper. But when that frontal cortex isn't working the way it should, those emotional reactions can get the best of us, and they can actually run the show. This is one reason why teenagers are said to make more emotionally related decisions than older adults. It turns out that the frontal cortex actually doesn't stop developing until well into our 20s. And so although these more evolutionarily ancient emotion regions of the brain have been developed in the teenagers, the frontal cortex is not fully developed to do its job at gatekeeping. And this is why there's been lots of research and anecdotal evidence by any of us who are parents that teenagers don't always make the most rational decisions. They can sometimes be guided by their emotions. But you shouldn't tell your teenager this, because then when they do something silly, they just say to you, "It's not my fault, my brain's not developed," and it's hard to argue against that. But you can have that in your wheelhouse. So we've been really interested in this emotional reactivity, and we've been studying what happens in the brains when people are stressed out about a particular situation, how this emotional reactivity occurs, and how it actually changes brain functioning to affect performance. And we've done this in a lot of situations, from public speaking to the athletic field. In particular, as of late, I've been very interested in academic situations, such as when, for example, someone has to do math and they're really anxious or scared about math. Math is an interesting area because, at least in our culture, it's completely socially acceptable for a very intelligent person to say, "Oh, I don't like math." A lot of us are math anxious, and it seems to be okay to be so. We've been really interested, though, in what happens in the brains of people who feel uncomfortable with numbers, whether we could see evidence of this emotional reaction to doing math, how it actually plays out to affect our performance, and in knowing what's happening in the brain, whether we can start devising techniques to help people perform better. So in one study we did, we actually invited people who professed to be really anxious about math and people who weren't anxious to come to our lab and have their brain scanned using an fMRI machine. We didn't tell anyone it was about math, what they were doing, or our math anxious folks wouldn't have shown up. But they got to our laboratory and we said, surprise, we're going to put you in this machine and we're going to have you do some math. No one ran away screaming. And what we did is we wheeled everyone into this machine. They saw a computer screen in front of them and they saw math equations. So they had to tell us, for example, whether 4 times 8 minus 17 equals 19. They had to answer questions like that in their head. True or false? Anyone know? It's a lot to juggle, right? And so we weren't actually so interested in whether or not people solved these problems correctly or not. What we are interested in is what happened in the brains of these math anxious individuals relative to their less anxious counterparts, not just during the math test, but even before the math task began, when they just knew they were about to do math. So what we did to look at this is we put on the computer screen a cue. They knew that every time a yellow square appeared, they were going to have to do some math problems, and every time a blue square appeared, they were going to do some reading problems. So that was the analog. And what we did is we looked at brain activity for these people who were really math anxious versus people who weren't, just when they were cued that the math was coming. That's all we were interested in here. And you guys are University of Chicago alums and friends, so I'm going to actually show you some pictures of brains because I know you can handle it. And I want to show you what essentially we found for our highly math anxious individuals, just in anticipation that they were about to do a math task. Okay, so here's the type of equation that they might have to solve. And you're looking here at 2 slices of brain. If this is my brain, the first slice, you're just taking off the left hemisphere and you're looking at it in an area called the mid-cingulate cortex. And if this is my brain on the bottom, pretend you're the doctor standing behind me, actually. You've sliced off the top of my head and you're peering over at a horizontal slice of an area on both sides of the brain bilaterally called the posterior insula. What we showed is that the more math anxious people were, the more they activated these areas just in anticipation that they were going to have to do a math task. And why do we care about these areas? The mid-cingulate cortex and the insula are actually part of our neural pain matrix. These areas are activated when we prick our finger with a needle or stub our toe. And what we're showing here is that math anxious individuals, when they just know they're going to have to do math, they weren't actually doing any math, their brains are sending out neural alarm signals like they're in physical pain. We've then shown that when these neural alarm signals go off, they actually shut down important frontal and parietal areas of the brain needed to do the math, and people's performance suffers. So we now are gaining some insight into just how these neural alarm signals work even in anticipation of a stressful event and how it actually changes our performance. And now the question is, what do we do with this knowledge? How do we actually change people's reactions to stressful situations so they can improve their performance? And for the second half of this talk, I'd like to take you through some of the techniques that we've come up with, both in our own laboratory and borrowing from lots of our fellow colleagues. We've been actually looking at ways to deal, for example, with the negativity that people feel oftentimes when they're getting ready to do something that they just don't want to do, where they think the stakes are high, where they might feel some pressure to succeed. And I think one of the greatest examples of this comes from swimming. So we've done some work looking at what happens in the brains of athletes when they're in stressful situations. And the research I wanted to tell you about next was work done by a group of sports psychologists at Team Canada. So the Canadians, it turns out, are really into the mental aspect of sports. I've talked to several different Olympic teams in the US, but the only Olympic committee I've been asked to talk to is the Canadians so far. And when I was going up to talk to Team Canada a couple months ago, one of my friends was saying, tell them the wrong thing, don't tell them the right thing. But I told them that science has no boundaries. We have to tell them the correct science here. But Team Canada is really interested because they've been interested in what happens when athletes fail to perform up to their potential, and they've used swimming as a test bed. And swimming's really great because you can tell whether a swimmer choked or not based on how well they swam at an important high-stakes event, the Olympics or the Olympic trials, relative to how well they swam in practice. success. And when I talk about choking, that's what I'm talking about. Worse performance than you'd expect given one's skill level because the stakes are high. And what Team Canada did, sports scientists invited swimmers who choked at the Olympic trials or the Olympics to their lab to have their brain scanned. They did something a little bit mean, but it was in the name of science. They put them in the brain scanner and they had them watch videos of their failed race. I know, it sounds horrible, right? These are athletes, they're tough. And what they were interested in is what was happening in the brain when these athletes were watching the videos. And sure enough, just like our really math anxious folks, these Team Canada showed that those athletes watching the videos of their failed races were activating the insula, the amygdala, these neural alarm signals that go along with poor performance. Then they did something really interesting. They asked the athletes to do an exercise where they taught them to think differently about their performance. Instead of dwelling on the failure, what they lost, what they missed, they asked the athletes to think about their failure in non-emotional terms and one broad thing that they might do differently the next time. So maybe this athlete got off the blocks late or didn't have a smooth stroke. They asked them to think about what happened and what they would do differently the next time. And every time they dwelled on this failure, they were told to do this. Think about one thing you did wrong and how you're going to change it in the future. They brought these athletes back to the lab and they scanned their brains 2 weeks later after having done this exercise, and they compared it to individuals where they didn't instruct them to do this exercise. And sure enough, they found that those athletes who'd been taught to think differently about their failure and what they were going to do in the future to succeed actually showed less activation in these neural alarm areas and more activation in important areas, the frontal lobe, the motor cortex, that we know are important for action. Team Canada thinks this is working. They pull their swimmers poolside now if they've had a bad first race and have them do this intervention to think differently about their future success. The moral of the story here is that our mindset matters. How we think about a situation and our ability to succeed or fail can actually change the workings of the brain to affect our performance. And knowing that is really powerful because it suggests to us that not only do we have to practice our skill, or our knowledge, but we have to practice the psychological skills of being able to think about why we should succeed. Our mindset carries a lot of weight. You see this in all sorts of situations. Our stereotypes, how we think about our expectations for success matter. So in the academic world, for example, there's some great research done at Princeton University where they brought women into their lab. These were a group of psychologists, and these were Asian women. And they asked these women before they took a math test to either think about the fact that they were women, so they had them write about their dorm, whether they lived in a same-sex dorm or a co-ed dorm. They had them dwell on the fact that they were women, or they had them think about their Asian identity. So they wrote about their family culture or history. Asian women came in, they either were told to focus on the fact that they were women, which has a negative stereotype associated with mathematical performance. Girls are not as good as boys at math, even though we know it's not true. Or they asked them to think about the fact that they were Asian, which has a positive stereotype associated with math performance. Asians are good at math. These research showed differences on the math test of whether a girl thought about the fact that she was a woman versus thought about the fact that she was Asian. When she thought about the fact that she was Asian, she scored significantly better on the math test than when she thought about the fact that she was a woman. Same kid, different thinking. How we think about ourselves and our ability to succeed can have a huge impact on success. This is true in all sorts of situations. We've brought University of Chicago undergrads into our lab. We've had women either check off their gender before they take a math test or check off the fact that they're an elite university. One leads to better performance on a math test, one leads to worse. How we think about whether we succeed or fail can go a long way to actually affect performance. And when you think about the gender and math issue, it's a really important one because this is a stereotype that's very pervasive in our daily life. So this was a t-shirt that was actually published or put on the market a few years ago from American Eagle Outfitters. This was on the shelves until outcry of parents and they got it off. The other t-shirt that was out there that came with it said, "I'm too pretty to do my math homework, so my brother does it for me." Right? So these are sending subtle signals to girls about their ability to do math. And we actually show that when we think about reasons we should fail, if we're aware of these stereotypes that they exist, they change the workings of the brain to affect our performance. When we get into that situation, our neural alarm signals go off, and they actually rob us of the brain power to perform at our best. And lest you think this is only an adult thing, we now have research from our laboratory showing as young as first grade, girls and boys are more likely to endorse the stereotype that boys are good at math and girls are good at reading. So we actually did a study where we brought first grade kids into our laboratory, and we told them a story about a kid who was good at math and a kid who was good at reading, and we asked them to draw the kids. And what we're interested in is whether kids drew stereotypical patterns. And here's what we saw. We saw kids were more likely to draw boys as being good at math and girls as being good at reading. So this is one girl in our study. We asked them if we couldn't figure out what the gender was. So this was a girl. She told us, and this egghead on the right, she said, was a boy. You might wonder where these stereotypes come from. We actually trace this back to their teachers, and it turns out that if a teacher of a first grader is anxious about her own math ability, girls are more likely to endorse these stereotypes by the end of the school year. So these stereotypes really matter, and how we think about our performance can really affect whether we succeed or fail. I want to spend the next few minutes telling you about a few more tips that we've realized and investigated about how we can perform our best when the stress is highest. So it turns out that how we think about whether we're going to succeed or fail matters. Thinking about concrete instances about why we should succeed. We're at an elite university, we've performed well in the past. Those are all really important things. Other aspects can play its role as well. So for example, it turns out that meditation is a great way to affect the workings of our brain to control our thoughts, especially in the moment. What a meditation does is essentially help practice the frontal cortex. It helps us learn to focus on what we want and not what we don't want, even when we're not in a meditative state. And we don't have to meditate for thousands of hours or become professional yogis to get these benefits. A study has been done, and there are several others that I talk about in my new book, showing as little as about 10 hours of meditation can actually change the structure of the brain. So here's actually one example from the study that was done. If this is the head up above, essentially what you're doing is you're just pulling out slices medially. And what these red and yellow dots are showing connections from the frontal lobe back. It's a white matter tract that takes information front and back. And what researchers did was they randomly assigned some people to go through meditation training, about 11 hours over the course of a month, and they had a control group that went through a relaxation training. So one group learned a meditation technique similar to mindfulness, where essentially you're learning to focus on what you want and not what you don't. And another group just learned to relax their body. And they actually scanned their brains and showed changes in the connections between the frontal lobe after 11 hours of practice of meditation over the course of a month. Now, of course, we don't know whether these go back if you stop meditating, but we know that the brain is plastic. When you practice juggling for 6 weeks, areas of the brain involving tracking motion change. And cab drivers who've spent their entire lives navigating the city streets in London actually have denser neurons in the hippocampus, the area of the brain involved in spatial navigation. So why wouldn't our ability to focus our attention, which is so important for what we do, also be impacted by training? And it turns out it is. And this is a really exciting area. Neuroscientists are jumping up and down. Of course, we have to admit that for hundreds of years, followers of Asian religions or cultures or particular religions have been very well aware of these sorts of findings. But as neuroscientists, we're very excited that we can now track some of this in the brain. Okay, so meditation works. What else can have an impact on our ability to focus our attention? It turns out that something as simple as walking in nature can be really beneficial. It turns out that our focus of attention, our ability to focus on what we want and get rid of what we don't, is like a muscle. It wears out over time. And just like you wouldn't practice the same muscle group over and over again, when you're always flexing this attentional muscle, it gets weaker. You need to give it time to rest and replenish. And one great way to replenish it is to actually take a walk in the woods. Now, this sounds kind of hokey, so I want to tell you about some of the research that have actually shown this is the case. A group of researchers at the University of Michigan brought students into their lab, and they had them do a bunch of different attention activities like you might see, or problems like you might see on an SAT or an ACT, so hard thinking and reasoning tasks. They then randomly assigned some of them to take a walk through the Ann Arbor Arboretum. They put a GPS on them, gave them a map. They took all their cell phones. They assigned other of them to go through a walk through downtown Ann Arbor during rush hour on busy Huron Street. Same distance, randomly put kids in the two categories, and then brought them back to their lab and again had them do these sorts of attention activities. And what the researchers found was that students who'd walked through the Arboretum were much more alert, they were sharper, they did better on these attention tasks after walking in nature than after walking through downtown. Now, why is this the case? It turns out that what being in nature does is allow us to rest our focused or directed attention, and it captures our attention in subtle ways. Maybe we are looking at the rustle of the leaves, or we hear the birds or the different colors. It captures our attention just enough to distract us and let that sort of directed attention time to rest and replenish. When we're in a busy city environment, we don't have that ability. We're trying not to get run over by cars. We're usually checking our cell phones. We're suppressing that urge to go into Starbucks for the 6th latte of the day. All of this takes this focused attention, and being in nature is a way to get that focused attention a time off, essentially. Now, you might be thinking, well, I don't have time to go through a walk through the woods all the time, but there's actually research showing that just looking at pictures of nature versus cityscapes can give you some of the benefits. Looking out the window, anything that gives you that time off, so to speak, can be really beneficial. Okay, so I've talked to you a little bit about meditation, about a walk in nature. Another great way to help us prepare for those high stress situations is to practice, but not just practice what we know, practice in the same types of situations we're actually going to be in when it matters most. To take a sports analogy, I talk about closing the gap between training and competition, and the idea here is that when we're getting up to give a talk, when we have to give a presentation, or when we have to shoot that free throw with all eyes on us, it's not the same to practice in a situation where we're not essentially mimicking the types of feelings we're going to have when the stakes are highest. So this is a picture of Coach Roger Reed. He's the basketball coach at Southern Utah University, and I love him as an example because when he got to their university, they were ranked 217th in free throw success. This is not a good number. And what he did is he essentially changed how they thought through free throws. He mimicked this idea that you need to practice in the same ways you're going to compete in, and he pushed them into the top in free throw shooting success. So how did he do this? Instead of just having the guys shoot free throws on their own at the end of practice, he would, during a scrimmage, blow his whistle, send a guy to the line. If that guy missed, the rest of his team had to run laps. It's not so fun to go into the locker room after a tough practice and your team is really mad at you because they all had to run a bunch of laps. And it's not the same as missing an important free throw when all eyes are on you, but essentially what it did is it got them to mimic the types of situations they were going to feel when all eyes were on them. Anything you can do to close this gap between training and competition. If you have to give a toast at a wedding with all eyes on you, practice in front of your friends and family. If your friends and family are going to watch you perform in a way that they might not normally, make sure you're practicing that way. If no one is around to help you, practice in front of a mirror, videotape yourself. Anything you can do to get used to the pressure can help close this gap. The military does it, the FBI does it. They train in the types of situations they're going to perform in. This is what we're paying big bucks for as parents when our kids take SAT prep courses. Sure, we're learning some tricks of the trade, but what we're really paying for is the ability of these kids to take timed practice tests next to the people they're going to be competing against when it matters most. Closing this gap between training and competition is invaluable for ensuring that when we have to show what we know, when we have to perform at our best, we're able to do it. Okay, so I've talked to you about meditation. I've talked to you about a walk in the woods. I've talked to you about closing the gap between training and competition. I want to tell you about one more technique that we've been really interested in as of late. And again, it's one that doesn't take thousands of hours or effort to perform, but is, we think, impactful because it's based on the science of what happens in the brain when we tend not to perform at our best. And this is actually something simple. It involves journaling. So we've been very interested for a long time in the worries and ruminations that individuals feel when they're about to be in a high-stress situation. And we have looked for literature that addresses these ruminations. And one literature that we looked at was the literature around clinical depression. And it turns out that when individuals are depressed, they often ruminate. And research has shown that one of the best ways to get rid of these ruminations is to actually have people journal about what they're thinking. And we thought, well, could we use this type of journaling activity to allow students to get rid of their worries before they go and take, for example, a high-stakes test? And so we know that these neural alarm signals go off when people are about to be in a stressful situation. Might journaling, as a way to actually download those worries from mind, put them on paper, allow students to reduce this neural alarm signal and perform better when it matters most. It's kind of like when you're up late, you can't go to sleep because you have all these things you have to do the next day. You wake up and you write them down, and then you can finally go to sleep. Anything that we can do to download these thoughts from mind might be beneficial. And so what we did is we were able to go into a high school, and we were able to test freshmen before they were taking the first final exam of their high school career. And we randomly assigned some of the freshmen to journal before they took this exam. And some of the freshmen were asked just to think about what wouldn't be on the final. So essentially, we went into the exam. It was a biology final. There were several different biology classes, but all the freshmen took the same exam in the same room. We handed out a packet to each student. Inside the packet, some students were asked to do a journal exercise, and some students were asked to just sit quietly and think about what wouldn't be on the exam. All the packets had a number on them. Students were told that their information couldn't be associated by name with what they wrote. After they'd done this for about 10 minutes, we collected the packets and left. Here's what students in the journaling condition were told to do. So this assignment will not be graded, they were told. We'd like you to take the next 10 minutes to write as openly as possible about your thoughts and feelings regarding the exam you're about to take. In your writing, we want you to really let yourself go and explore your emotions and thoughts as you're getting ready to start the exam. You might relate your current thoughts to the way you felt during similar situations in the past. Please try and be as open as possible. That's it. 10 minutes before the exam, we gave this to students. Some students were asked to do a control exercise. We collected their packets. Then they went about taking their exam. Now, 8 weeks before we actually did this, we went into students' homeroom classes, and we were able to get measures of their test anxiety, so how much they profess worrying when they take an exam. And what we thought is that if what this journaling does is essentially tamp down this neural alarm signal, then the writing should be most effective for those students whose signal is the highest, the ones that tend to worry. So we split up our students into two groups, one who professed to be high in test anxiety and one group who professed to be low in test anxiety. And then we looked at their exam performance across the school year before they'd got our intervention, and then their final exam scores. And I actually want to show you some data from this study. And what you're going to see is that for the students who are low in test anxiety, doing our writing exercise essentially had no effect. But for the students who are higher in test anxiety, we were actually able to boost their exam scores from a B- to a B+ just by doing this 10 minutes of writing. No change in curriculum, no extra teachers. All we're doing is allowing those students who are most anxious a way to get rid of that anxiety before they take their test. Okay, so here's the data. What we have on the bottom here are their grades from the fall, winter, spring, and then the final exam, right before which we did their intervention. On the right are our low test anxious students, and accuracy is on this vertical axis, so higher is better. What you can see is that across the school year, our low test anxious students get higher in terms of their scores on these exams they took at fall, winter, spring, and then the final. The dotted line is our control group, those who thought about what might not be on the exam. The solid line is our writing condition, and what you can see is there's no effect of our manipulation. But you see a different pattern of results if you look at those kids who profess to be most anxious about taking tests. Before we did anything, before the final, there was no difference in our groups, which is good because we randomly assign people to condition. But after the final, those students who were in our expressive writing group bumped up about 6 percentage points just as a function of doing our writing exercise. The idea here is that if we understand a little bit about what happens in the brain and body in stressful situations, then we can start developing techniques to help students, especially those who profess to be most anxious when they take tests, perform at their best. And we find this really exciting because it really suggests that we need to think about the psychological aspects of high-level performance and not just the content or skills that we're learning. Now you might be wondering what students wrote about, so here's one student's sample writing. This is a girl in our study. She wrote, "When I first think about the upcoming final, I feel really stressed. I'm worried that it will be on everything I don't know very well and that I haven't prepared enough. This really stresses me because I'm always worried about grades. I really like doing well, and when I don't do so well, it upsets me. I have really high standards. As I continue to think about the final, I relax significantly. I realize it's only one test. I realize I've studied enough. What I don't know, I don't know. I think I know everything that I need to. I realized that I was blowing this out of proportion. I don't have to worry as much. It's only one test. It won't affect my life drastically, so now I'm okay. I don't have to worry as much. It's not as stressful now. I know I'll do well. Great even," she writes. "I know this stuff. I've learned what my teacher taught me. I don't have to worry. There's still an undertone of stress. I'm still a little bit worried, but everything will be okay. I know I'll do as well as I can." So they did this sort of brain dump, right? And when we analyzed these stories, the writing, to see if we could see things in the writing that predicted performance. And what we found is that those students who by the end had gained some insight into their situation, who realized it wasn't actually that bad. It's kind of like when you write that really mean email to someone that you're not going to send. You just write it and you feel better because of it. We found that those students who gained the insight did the best. I will say, just as an FYI here, one of the biggest sources of stress that students wrote about were parents. They were worried they were going to perform poorly and their parents were going to be mad, so you can just take that as a piece of data if you'd like. But we know that this writing seems to have an effect because it allows students the opportunity to almost download their worries from mind. In essence, they don't think about the situation as high stakes when they get in there. And we think these neural alarm signals are tamped in a way that allows them to utilize the brain resources that they need to perform at their best. So I've talked to you about a bunch of different techniques: meditation, a walk in the woods, closing the gap between training and practice, writing and journaling. One last technique I want to leave you with is actually almost an oversight, I would think, but something that's so simple to do that can have a big effect. And it's actually just how we hold ourselves, how we hold our bodies. So it turns out that we often think of the face as portraying all the information about how we're feeling. But it's not just the face, our bodies matter too. If you're a student who walks into a test like this, it actually sends signals to your brain about how you're going to function. But if you walk in, head held high, wide stance, that changes our ability to perform at our best. And we don't think this is true, so I want to just show you an example of this. So as I said, we often think about the faces expressing our emotions. But if you actually look and have people predict people's emotions from facial expressions, it's not so easy to do. So I'm about to show you a bunch of faces of tennis players. They're either winning or losing points at Wimbledon. So you'll know who some of these people are. And what I'd like you to do now is try and predict whether they just won or lost a point from their faces. So what do we think? Won or lost for number one? Lost. Two. First, I just want you to see that you're not agreeing with each other here. 1, 3, 1, 4, lost. 5, 1, 6, lost. It's hard, right? But the bodies, it's easy to predict from the body whether someone just won or lost. How about this? Top, won or lost? Bottom, right? Our bodies send signals to other people about how we should feel. How we stand actually affects what others see about us, and it actually turns out that how we stand changes levels of hormones circulating in the brain and body to affect performance. When we stand tall, when we stand proud, when we stand wide, there are studies that show that it can actually increase testosterone circulating in the body and allow us to make oftentimes more competitive and better decisions when it matters most. Little things can have big effects. The power is in understanding some of the science behind human performance, and then all of a sudden you have this toolbox of techniques that you can call upon to ensure that all that practice that you do, all the skill you acquire, all the knowledge you have, is able to be put forth when it matters most. So I think I'll end here by arguing that success is really simply more than what we know. Our anxieties, our attitudes, our emotions are critical. And the idea is that if we have a little bit of insight into the science behind human performance, then we're just in a totally different place to ensure that we can put our best foot forward when especially the stakes are highest. So thanks very much. I'm happy to answer more questions. And just to mention, I talk about most of this research in my 2 books.
research absolutely fascinating, and I was wondering, you mentioned that the brain changes as we grow older. What kind of studies have you found on older people? For example, corporate executives or people in business as opposed to students, and how their stress manifests itself.
Yeah, so a lot of this work plays out in very much the same ways, although we do know that the brain changes as people grow older. It turns out that we think that maybe this happens like 60, 70, 80, but cognitive decline from our top state is in our mid-30s, so it starts early, although our knowledge, we make up for it very quickly. But some of the most interesting studies are looking at benefits of, say, how we use our body for older adults. So there's work I talk about in How the Body Knows Its Mind. In fact, I have a whole chapter devoted to this. It's exercise. And it turns out that exercise not only is good for physical fitness, it's good for mental fitness. And there's a great study that was done a few years ago with older adults that showed that a year-long exercise program, and they had as a control group, so they walked a couple times a week around a track, and they had as a control group just a stretching group. A year-long exercise program reduced the decline in the mass of the hippocampus, which is involved in memory and navigation, by about 2%. So although once you get to a certain age, your brain actually shrinks over time, and the hippocampus is a very important area for memory, those who did this exercise program didn't show this decline. So there's really some amazing things, I think, that we can learn about staying cognitively fit in our older age that have to do with, for example, how we use the body, and that certainly extends to stressful situations as well.
Yes, great. Could you talk a little bit about the pep talk, how that fits into dealing with jokes of the win-win for the giver speech?
Pep talks. If you characterize pep talks as thinking maybe about what happened with the Canadian athletes, where they actually talked about why they should succeed and you're specific about it, I think that can be really beneficial. It's not, though, this yip yip hooray attitude. What you really have to do is think about why you should succeed. You have to provide people with the mindset about, and provide them with some tools about why they should perform well. Maybe they've practiced really hard, they've beaten this team before. Anything that they can hang their hat on is really especially important. Just like getting women to focus on the fact that they're at this elite university, it gives them something to hang their hat on as evidence about why they should succeed. So the pep talk can be great, but it needs to, I think, abide by some of these principles.
Since the prefrontal cortex is less developed in adolescence, do you find any differences in adolescence, or maybe even young adolescence, in some of these responses, such as the analysis paralysis?
Yeah, that's a great question. It's a really great question, and we haven't done so much work comparing young kid athletes to older athletes, for example, to ask what happens. But I will say one thing, and I talk about this actually in both books, but when we're young, we actually tend to learn skills with less involvement from the frontal cortex to begin with, because it's just not as developed. And that actually is thought to be a buffer against some of this over-attention, because you didn't think about it so much to begin with, right? So I wrote a blog for Psychology Today, and I have one of the blog posts in there about thinking and learning like a kid, training ourselves to learn like we would when we're younger. And there's actually some research suggesting that it can be beneficial both in sports situations and also in something else that turns out we do much better at as young kids in learning foreign languages. It turns out that kids grasp accents of foreign languages, and when you learn a foreign language at a very young age, you learn it to a higher level of perfection than you ever could as an adult. And studies that have tried to mimic how kids learn foreign languages often show better outcomes than studies that don't use those sorts of techniques. But it's a great question.
Over the last 10, 20 years, we've seen electronic media becoming more and more important. People texting, people using phones, people using emails. As you look at these coping strategies, many of them are meditation, journaling, they're unplugged. What type of research or what type of work are you doing in the correlation between kind of how people are communicating now to performance anxiety?
Yeah, I mean, I think a lot of what I talk about in How the Body Knows Its Mind is really resonates with this unplugged sort of idea, and this idea that we do need to give this controlled attention time to rest and replenish. And if we're constantly on our phone or checking our email or we're trying to text while we do our homework, that's the opposite of being unplugged, right? And there's some really interesting research out there showing that although people think that they can dual task really well, they actually cannot. So usually when you're doing two things at once, both things get worse, even though you don't necessarily think that's the case. In fact, there's 1% of the population, I think, that we call super taskers, who can do two things at once very well, but for the other 99%, it doesn't work so well. And actually, it drives me crazy because I have a teenage daughter, and I walk into her room, and I catch her like on the cell phone while she's doing her homework, texting. I say, "What are you doing? This is my research. You can't do this." And she says, "No, Mom, I'm a super tasker." I say, "No, that's highly unlikely. It's only 1% of the population." But I think the idea here, the important take-home is that we aren't often such good observers of how it's taxing us, but the research suggests that when we're always double, triple tasking, it's making everything a little less efficient.
Does any of this change given a brain that's injured?
It's a good question. I mean, there can be lots of different types of brain injuries, so certainly cognitive function can change as a function of brain injury. But we haven't looked specifically at particular types of injuries and how they affect it. But you could imagine if you have a frontal lobe injury and you're not as good at, say, tamping down those signals from amygdala or insula, you could have more outbursts, things like that. And there's actually historical neurological cases to support this. So one of the famous cases was by a man by the name of Phineas Gage. He was a railroad worker in Vermont in the late 1800s, and he had the job of tamping down the gunpowder that you then blow up, and you blow a hole in the side of the mountain. And he was tamping it down one day, and the gunpowder exploded, and the tamping rod went up through his frontal cortex and out the other side. And it's like one of the most famous cases because he was up like within minutes walking around. He had a big hole in his head, but he was up walking and talking, and he recovered, they thought, relatively quickly. Within a couple of months, he was back at work. But one of the most interesting effects was that he was having emotional outbursts, and he wasn't being reasonable, and he was making decisions that you or I wouldn't make. If I offered you $1 now and $100 2 minutes from now, you'd probably wait for the $100, but he would take the $1. And what researchers have concluded from his case and others is that one of the things that happens when you have oftentimes large-scale damage to the frontal cortex is you're not able to balance that inhibition of emotion and these sort of desire for needs in the same way, and you fall prey to your emotions because of it. So I would say that he was in like a hyper choke state at all times.
Tying to the business world, is there any studies, have you done any, are they out there about the super intelligent person who works themselves up to the top job or close? They're so smart, analysis paralysis hits, they can't lead people, the company falls apart because they can't make decisions, the emotional intelligence in their head, they're just so smart, they think about all 50 ways to get something done instead of leading the charge and creating a team to get it done.
Yeah, it's a really interesting issue, right? I mean, the Nike sort of motto gets invoked here where sometimes you just have to do it, right? If you're sort of paralyzed by the details. And I think this comes out in all sorts of ways in business situations, not only in terms of making decisions, but especially when the stakes are high in terms of communication. So we often see mistakes get made in terms of the transfer of information from one person to another, whether it's by email or even face-to-face, when there are demands on everyone, when there's a time crunch, or when someone's watching. And it turns out that changing our communication, some of the things we do, can be really important for ensuring success when it matters most. I haven't done case studies per se of these top business executives, but a lot of the factors that we identify that play into poor performance do play out in these sorts of situations, especially when people are at the highest level and all eyes are on them all the time.
Follow up on the question here about elderly people and exercise and the research you discussed. I was talking to a 90-plus-year-old friend yesterday who was just saying to me, she thinks for her it's not just exercise, it is following an aerobics instructor. It's something about the mind, body, listening, having to follow instructions. And is there anything in your research that
Yeah,
My point to that, I was really surprised, and I thought it was an interesting observation.
it's a really interesting observation. Well, we certainly know that keeping cognitively active is important too, and it sounds like through her exercise even, that's one way to test herself cognitively, right? She's pushing herself to have to follow and mimic and match. But it'd be interesting to think about whether exercise programs that actually involve that cognitive component in it can be beneficial. There is some work that I talk about in How the Body Knows Its Mind about acting classes for older adults as a way to help enhance cognitive ability later in age, and part of that is memorizing lines and embodying different people and thinking about goal-directed action. So you could see it playing out in that, but I think it's a really interesting observation.
We have time for one more question.
Thank you. I'm wondering whether there's been much effort to apply these principles to prepare people for the very high intensity, high stakes business of combat leadership.
Yeah, that's a great question. University of Chicago. Banner is falling. You did so well for so long. So certainly military leadership is very interested in these ideas. I've done talks for high-level leadership there several times, and there's a whole section interested in human performance, and lots of the principles that get studied and talked about are put in place in lots of these situations. Another area where I've been specifically involved is having to do with people getting out of high-pressure situations that are dangerous in their jobs. So I was part of a national science panel that talked about and wrote a report about coal miners and how they escape from emergency situations, and talked about training them in a way that allow them, when they need to escape from coal mines that are life-threatening. And as you know, over the last several years, there's been several deaths from coal mining accidents, and we as a body from the National Academy were charged with determining and talking about the research that would allow these coal miners to be trained in a way that would allow them the cognitive tools as well as the physical tools to get out of these stressful situations and save their lives. Okay, so I think I'll end there. Thanks very much.